So next in the homework, you're going to see critical values, questions that ask you what is a Z critical value or what is a T critical value. And because we're using Statcrunch, we don't have to do as much with those calculations, but if you've looked through the notes, you see the formulas. The critical values are part of the formulas when you're doing it old school, when you're doing it with the calculator. So we're going to learn how to find the critical values with the population standard deviation known, which is the Z values. We are also going to use that for proportions, or the T value, which is population standard deviations unknown, and that's new, and we're going to be introduced to that in this video. So critical values are values that separate sample statistics that are probable from sample statistics that are improbable. Recall the empirical rule and values that did not fall between the scores of -2 and 2 or probabilities below 5%. Critical values identify those values that fall in either the left tail or the right tail of distributions. For the scope of our class, we will be using the normal distribution or the T distribution to find these values. Fortunately, included in Statcrunch is the normal calculator and the T calculator that allow us to find these values. Critical values are used as essential parts of more complex statistical formulas. And although T-stats and Z-stats take care of these calculations for us, it is important we understand and are able to use the technology to calculate these values. So the first example, this is from the notes, and we're looking at 80% confidence levels, 95% confidence levels, and 99% confidence levels. And we've already done these in a previous section, but essentially we use the between function and the normal calculator. And as you see what I have the 0.8 here, the 0.95 here, the 0.99 here. So just for a moment, let's step up to Statcrunch, Stat, Calculators, and Normal. I don't need to touch the mean. I just click the between button. And I'm going to put the 0.80% in here. And click compute. And there I have a Z-score. I'm only going to use the positive, the 1.2816. One of the advantages with using a program like Statcrunch is that it never rounds till the end. And a lot of times when these Z-scores get rounded, we move farther away from precise answers. We've discussed that in class before. All I have to do the next one is just change this to 95%. Oh, that's 65. Again, my typos. And that's 1.96. Which is we see frequently. That's a Z-score we'll see frequently. We're going to see these again in hypothesis testing in the next chapter. Like I say, that's a common Z-score. The last one is 99%. And I'm going to click compute. And there I get a 2.5758. So going back to our document, we just finished the section on the normal distribution. I don't think this part should give you any trouble, but that's how you would find these critical values. You notice I have 80% or 80, and you notice each one of the scores. And these are Z-scores because we're using the normal distribution. But let's meet our new friend, the student T distribution, which has a colorful history. We got the Guinness Brewing Company of Ireland and one of their employees, William Gossip Jr., to thank for this distribution. If you're interested, I have a video in Brightspace you can look at that talks about the history of it. Kind of a little bit kind of cheesy, but still, if you're curious of how where this particular distribution originated. But the reason for it was the company needed a way to handle small sample sizes characterized by greater variation. Although it's similar to the normal distribution in that they are both bell-shaped, there are key differences. And before I start going through this list, I want us to remember, too, that since we're going to have small sample size, they'll have to tell us that the distribution is approximately normally distributed. And we will see that in several of the questions. So the student T distribution is different for different sample sizes. The student T distribution, same bell shape. reflects the greater variability with wider distributions that is expected with small samples. The student distribution has a mean of t equals 0, just like the standard normal distribution has a mean of z equals 0. The standard deviation of the student t distribution varies with the sample size and is greater than 1, unlike the standard normal distribution, which has sigma equal to 1. As the sample size gets larger, the student t distribution gets closer to the normal distribution. The t distribution is from a family of curves, each determined by a parameter called the degrees of freedom. We're just going to abbreviate it df. And calculating degrees of freedom require an adjustment to the sample size to offset the greater variability found with small sample sizes. The df adjustment for the student t distribution is n minus 1. So what does this look like? So we're going to go into the homework. This is homework problem 5, and you'll have to do both z and t critical values on the test. But it's find the critical value t for the confidence level c equals 0.8, a sample size n equals 21. Well, before I jump into Statcrunch, I'm going to make my adjustment over here for the degrees of freedom, the n minus 1. So 21 minus 1. So my degrees of freedom is 20. So I'm going to show you how to do this in Statcrunch, but if you'll notice for the degrees of freedom, I entered the 20 here. I'm using the between again, 0.8, and I'm only going to use the positive here. So let's go back to Statcrunch and find this little calculator. So I'm going to get rid of that. So Stat, calculators, and down here we see the t calculator. When I open that up, and I'm going to use between, and this was going to be 20 for the degrees of freedom, and this was 0.8. And when I click compute, there is 1.3523, which is my critical value for a 0.8 confidence level for a confidence interval. Remember that the only time we're going to use the t distribution is when we're creating a confidence interval for a mean when the population standard deviation is unknown. Now we will use the t distribution again when we get into hypothesis testing, which is the next chapter. So I hope that was helpful. I'm going to get this posted right away. We have, I think, 2 more videos, maybe 3, and we'll have everything you need for chapter 6. Take care.